here. Okay, so a little bit of a recap. So, the important equations that we need or that we are interested in when we discuss things that are adiabatic. Well, adiabatic means dq equals 0 or q equals 0. Either one is fine, depending on if you're talking about the differential version or the complete finite version. So what you end up with is du equals minus w, or delta u equals minus w. Sorry, du equals minus dw. Minus dw. Okay, now for a reversible adiabatic change of state. For a reversible adiabatic change of state. So we can have an adiabatic process, and we can have a reversible adiabatic process. Remember, we can have an isothermal process, or we can have a reversible isothermal process. That reversible puts a little bit more of a constraint on the situation. So for a reversible adiabatic change, now for an ideal gas, we had CV dt equals minus P dV. That's the basic equation. You can go ahead and take care of the integration. Once you integrate, you end up with the following. You end up with CV times the ln of T2 over T1. This is the basic equation. What we did, just like this stuff right here, that was just, we took it a little bit further. We just rewrote this in a different form. Minus R ln V2 over V1. Personally, I like to stick with this equation. This is just stuff that you're going to see in books. I wouldn't worry about it too much. This is the important equation right here. Or, if you prefer, because this molar thing is just equal to the heat capacity divided by N, you can go ahead and put this into here and get this particular version of the equation. You can get CV times the ln of T2 over T1 is equal to minus NR times the ln of V2 over V1. I think most kids, actually, they like to see the N there, the moles, as opposed to working with this with a line over it, these molar values. I'm like that too. I actually prefer to see the moles there. It's just a personal taste of mine. So that's about it. This pretty much takes care of the adiabatic process. Anytime you see anything that's done under adiabatic conditions, you want to set dq equal to 0 or q equal to 0. This is going to be the equation you work with. Under an adiabatic reversible condition or reversible adiabatic changes of state, in the case of an ideal gas, this is what you're dealing with. Thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.